Look, if you're a C++ developer, we've all been there, right? You start a project, and before you know it, you're staring at one single giant file of code that has become a tangled, chaotic mess. Well, today, we're gonna untangle it. We are going to turn that chaos into a clean, professional, and totally scalable project. Let's get right into it.
Have you ever found yourself completely lost in one of your own files? You know the one I'm talking about. It's hundreds, maybe thousands of lines long. Trying to find a bug feels like finding a needle in a haystack, and adding a new feature, forget about it. If that sounds painfully familiar, trust me, you are not alone. And this is what we're talking about, the single file nightmare. It's a super common way for projects to start out, but it is just not sustainable in the long run. But here's the good news. There are powerful, standard techniques to fix this for good, and that's exactly what we're going to dive into right now. So, where do we even begin? Our first step is a process called refactoring. The best way to think about it is like this. Before you start building brand new shelves in your house, you've got to clean up the existing mess first, right? That's exactly what refactoring does for your code. Now, this is a really crucial idea. Refactoring is all about improving your code on the inside, making it cleaner, easier to read, more efficient, without changing what the program actually does on the outside. It's about shifting your mindset from just making it work to making it work well, so it's ready for the long haul. So why even bother? What's the payoff? Well, refactoring directly attacks the biggest problems of messy code. It makes it more readable, so you or your teammates can actually understand what's going on. It slashes complexity by breaking down huge functions into smaller, manageable pieces. And all of that leads to the biggest win. Your code becomes so much easier to maintain and debug down the line. Okay, so our existing code is tidy. That's a huge step. But now how do we build a structure that prevents that mess from ever coming back? This brings us to a fundamental concept in C++, splitting our code up using header files. This right here, this is probably the most important concept to really get your head around. Think of your header files, the .h files, as a restaurant menu. They tell you what is available. You know, the names of the functions, the structure of your classes. Then you have the source files, the .cpp files. Those are the secret recipes in the kitchen that explain how each dish is actually made. The what versus the how. That distinction is everything. And listen, don't think this is just for some huge enterprise-level project. No way. Splitting your code makes it instantly easier to manage, even for small projects. It's an absolute lifesaver for teamwork because now different people can work on different files without tripping over each other. And bonus, this is the foundation for creating your very own reusable code libraries. So, with all these new files, how do the pros actually organize everything? They use a standard called the Pitchfork Layout. This is pretty much the industry standard blueprint for a clean, scalable folder system that will make your projects immediately look and feel professional. First up is the include directory. Think of this as your project's public storefront. It's your API, your application programming interface. It's the public contract. All of your public header files go in here, and they tell other developers or other projects exactly how they're supposed to interact with your code. Next up, we've got the SRC directory. Now, this is the engine room. This is the private, behind-the-scenes part of your project where all the real work happens. Your source files, the .cpp files with all the logic, they live here. And any private headers that are only used internally, they go in here too, tucked away from public view. And finally, to keep things really pristine, we create a couple of other folders. A /build folder is where all the compiled machine-generated files go, and a /tests folder is for, you guessed it, all your tests. This is so important for keeping your precious source code completely separate from all that other stuff. And here it is, all laid out. This gives you a perfect snapshot of that Pitchfork layout. /include for your public API, /src for your private implementation, /build for the compiled output, and /tests to make sure everything works. It's simple, it's logical, and it's the gold standard for a reason. It just works. All right, so we've got the structure, the blueprint is there. Now let's talk about the essential can't mess this up rules for writing header files that actually work and don't cause a cascade of compiler errors down the line. If you remember one thing from this entire section, please make it this. At the very top of every single header file you ever write, you need this one line, #pragma_once. This is what's called an include guard. It's a non-negotiable golden rule that stops the compiler from getting confused if it accidentally includes the same file more than once, which, trust me, can cause a world of pain. So the day-to-day workflow is actually super simple. Step 1, you declare your functions and classes in a header file, that's the what. Step 2, you write the actual code, the implementation, in a matching source file, that's the how. And step 3, anytime you need that code, you just #include your header file using double quotes. That's it. Declare, define, include. Simple as that. So let's wrap this part up with a final, super simple checklist. What to do. Always use include guards. Always keep your function prototypes and class declarations in the header. What not to do? Never, ever write full function definitions in a header. And please don't declare global variables there. Those last two are a recipe for disaster. And just like that, you've done it by combining these two big ideas. First, refactoring your existing code to clean it up, and then setting up a proper professional structure like the Pitchfork Layout. You've taken one giant leap from just writing scripts to building professional-grade software. So now your code isn't a tangled mess anymore. It's a clean blueprint, ready for anything. The only question left is, what amazing things are you going to build with it?